So today we'll be presenting our machine learning and parallel computing assignment. We'll be doing predicting car prices.
Hi, my name is Nicholas Tim Teng Ho, and my student ID is 0349242. Okay, so this is introduction of our project. So basically, the automotive industry plays a crucial role in our country economy, with the new car market taking a huge portion of it. So the pricing of new cars is intricate and complex, and it is influenced by multiple factors such as drive wheel, engine type, cylinder number, engine size, fuel system, horsepower, and many other factors. Which is why accurate pricing is very important because it directly impacts the sales quantity and profit margin of the authorized dealers. The competitive and dynamic nature of the global car market also require companies to give reasonable pricing in order to be able to compete against other rivals. So for this project, our research goal and objective is to develop our research goal is to develop a prediction model to help Geely Auto estimate prices accurately based on various influencing factors both internally and externally. So our aim is to assist Geely Auto in pricing their new car competitively in the US market. Our research objective is to address the challenge of the pricing car models in a dynamic and competitive market. So we had conducted a literature review, so we are able to provide a solid foundation for our solution. We also utilize appropriate machine learning models such as decision tree, multiple linear regression, and KNN uh, to gain insights. Uh, no, sorry, the literature review that we have refer on have also utilized appropriate machine learning models to gain insights on the data. And advanced machine learning algorithm has been applied to improve the accuracy of price prediction as well.
So I'm Muhammad Danial Ikhwan, student ID 0351545. Today I'm gonna talk about the data preparation. First of all, I'm gonna talk about the data set which we chose is actually from Kaggle. It's a variety of American cars, including key attributes like car ID, model, fuel type, engine specs, and price. So, how do we prepare the data? First, we do handle some missing values. How we do that? We fill some missing numerical values using the median or mean and replace missing categorical values with the most common occurrence. Second of all, we do the outliner detection. Why we do this? Because it actually can distort the predictive modeling. So by using techniques like interquartile range, we can easily identify and remove these outliners from key numeric features. For evaluation strategy, we use two methods, which is R squared values and mean squared error. This can easily determine the accuracy and the reliability of our data set. So for data visualization, there's two main part that I want to show in this presentation. First of all is this section where we use the describe function to summarize numerical columns providing statistics like mean and standard deviation. um, we also it also provide like a very quick and detailed summary of all the numerical columns. So by using this describe function, we actually can see the key trends and variations at a glance, so it makes us easier to start analyzing and comprehending the data set. Next is the correlation metrics. So we did some calculation of correlation metrics to identify relationships between price and other numerical attributes using tools like heat maps, scatter plots for visual representation. So as you can see from the diagram, that is our heat map. So from the heat map, it's very easy for us to observe the positive correlations with warmer colors and negative correlations with cooler colors. So this method of what we so-called visualization is actually very useful in order to spot trends, patterns, and the strength of relationship within the data set.
Hi, my name is AZAD IBNE. My student ID is 0361988. So I'm going to talk about multiple linear regressions. So features of selections and data splitting. So the selected features are horsepower and curve weight and range in size. And the data splits is 80% for training and 20% testing. Model training: build and train the multiple linear regressions model on the training sets. Use the training data to determine the coefficients and intercepts. The model evaluations: elevated model performance using the R-square and RMSE metrics. R-squared 0.891 indicating high variance explanations, and RMSE is basically demonstrating accuracy in predictions. Next slide.
For decision tree, the selected feature is engine size and the data split is 80% training and 20% testing. So we build a decision tree regressor and train it on the training data to learn the relationship between the engine size and the price. The performance is evaluated using R square MAE, MSE, and RMSE metrics. And the achieved R square value is 0.923, which indicates 92.3% of the price of the variance of the price variable can be explained by the independent variables, which is quite a high value and showcase a very strong positive relationship between the dependent and independent variables. So for hyperparameter tuning, we utilize grid search CV to optimize the hyperparameters, and we managed to achieve 81.09% accuracy rate with the optimized hyperparameters. For visualization, we decided to visualize the decision tree structure using a scatter plot. So in the scatter plot, we plot the actual price versus the predicted price uh, for for us to visualize and understand the differences between the actual and predicted price more clearly.
So right now I'm going to talk about the k nearest neighbors, featuring the selection and data splitting. Selected features are like engine size, horsepower, and curb weight, and the data splitting is 80% for training and 20% for testing. The data scaling, importance of featuring scaling of KNN. Method used is over here is like minimum and maximum scaling, standardizations. The model training and evaluations. Trained the KNN model on the training set, evaluated performance using the R square and RMSE metrics. The hyperparameter tuning. Utilize the grid search CV to determine the optional number of neighbors at an optimal the in neighbors found is 3.
Hi, my name is RAISA BINTI Muhammad ZEKRI, student ID 0352296. So here's a concise comparative analysis of the three models, highlighting their strengths and weaknesses. So the first model is multiple linear regression. So the first strength is that it offers interpretability through coefficients, making it easy to understand the impact of feature on car prices. The next strength is that it generally is less prone to overfitting compared to the more complex models. Moving on to the weaknesses, is that it assumes linear relationships between features and car price, which may not capture complex nonlinear relationships. The next weakness is that it is limited flexibility in modeling complex data patterns. For the second model, decision tree regression, the strength is that it can capture nonlinear relationships between features and car prices effectively. It also requires minimal data processing as it can handle both numerical and categorical data. For the weakness, it's prone to overfitting, especially with deep trees and complex data sets. and it may not generalize well to unseen data if not properly pruned or regularized. For the last model is that K nearest neighbor regression. The strength is that it is simple to implement and understand and robust to outliers in data due to its non-parametric nature. For the weaknesses, it's that accuracy can be sensitive to the choice of the number of neighbors, and it requires careful scaling of features as it is distance based. Next slide. Lastly, for conclusion, these are the key findings. So the first key finding is that for model comparison, decision tree regression emerged as the most effective model for predicting car prices, followed by KNN and then multiple linear regression based primarily on their R-squared values. For the impact of engine size was identified as a significant factor influencing used car prices, aligning with established automotive knowledge. For hyperparameter adjustment and visualization, utilizing this technique significantly improved model performances and interpretability, exemplified by the decision tree classifier, achieving an accuracy increase from 81.09% to 83.21%. For the recursive feature elimination, implementing RFE methods can enhance both model performances and the interpretability by identifying and removing irrelevant features, thereby optimizing the predictive accuracy of the models. For the insights and contributions, the study contributes valuable insights into forecasting used car prices through data-driven approaches, highlighting the effectiveness of various machine learning and optimization methodologies. Lastly, for the practical implications, by identifying key factors influencing car prices, the study provides valuable information for both consumer and industry professionals, aiding in competitive pricing strategies in the market. Thank you.